Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Welcome to the SEI Podcast Series. My name is Joe Yankel. I'm a senior engineer in the Software Solutions Division of SEI. We've had many discussions on Rust and the benefits of using this programming language, especially in the DoD, the benefits of memory safety in critical systems. And we want to explore a little bit more about this subject. Today I have with me Vaughn Coates. He's a DevOps engineer, also in the Software Solutions Division. Welcome, Vaughn.
Welcome. Thank you.
So, since you're new to the podcast series, why don't you tell me a little bit about yourself, what brought you to the SEI, and what really gets you going here?
Absolutely. So if I was to look back, my experiences that led me here really started in full stack engineering, as we like to call it. Before I joined the SEI, I was a full stack software engineer doing consulting work, mostly in the financial sector, working with, I think, very traditional, typical languages we still see here, even in the DoD, languages like Java, Python, C#. And I ended up finding Rust actually very much earlier than that. But at the time, it didn't really click for me. So once I joined the SEI and I started working on some projects, I had a mentor come to me and ask me the question, hey, how would you like to learn a new language called Rust? And I luckily got to tell him, well, thankfully I already know this one. And at the time, right, we've been building a lot of web systems, a lot of, different pieces of scripts. And, Rust ended up changing my thinking in a lot of different ways.
So one thing I hear about Rust adoption is it might take a workforce a long time to do. How was your experience in really diving into Rust and maybe using it beyond your initial forays into it?
Yeah, so really, like I said, I was doing it in school, but once I actually got to work with a real project with real customers, that was when I had a chance to really dig in. And once I finally got the chance to sit down and look into it, it really kind of changed my whole world and the way I thought about software engineering. The way it handles things like memory, the way it handles your errors, the way it even tries to prevent you from making simple little mistakes really made me think that, wow, this is something different. So once I dug into it, that's when I started working and trying to build systems to actually solve, I would say, real problems. Problems like observability, problems like building sustainable, scalable platforms. Those were the problems that I found a lot of the times our customers here at the SEI tend to run into a lot.
We certainly do. So can you give me examples of, how a different language might have memory errors and how that maybe affects the life cycle of maintaining that software versus your experience in patching Rust code?
Absolutely. I think one of the easier targets is a language like C++, right? A language that was initially, if we look at C itself, was developed ages ago. I think, if I can't give a specific number, unfortunately, I think it was about like late 70s, early 80s when that language first came out. And while it did change the game for sure, it was a language that still required you to really think ahead, right? Trying to anticipate how much memory you were trying to use at any given time and then cleaning up after yourself at any given moment. Rust is a language that simply just does not necessitate you to do so because of its borrow checker.
So tell me about the borrow checker. I understand it's a feature in Rust that's really allowing you not to make some of these errors.
Absolutely, yeah. It's something that I think a lot of developers tend to really, for lack of a better word, crack heads with, or like rub their heads against, because it's something that, like I said, does not allow you to make mistakes. Early on in my computer science studies, we were taught a lot about how these machines tend to work at the lower levels, right? Whenever you're calling a function, whenever you're actually trying to define some piece of data that you're trying to use, a lot of things happen under the hood that require your computer to, jump around to particular places or try to access data in particular places. And in a language like C++ or C, you have to actually anticipate that. But Rust, in its borrow checker, take that thinking away from you in terms of it knows where the data is, it knows who owns it, and it knows how it's being used at any given time. And that allows you to actually focus on solving the problem versus trying to anticipate every little thing your computer is trying to do, in my experience.
That's great. Now, we know that C++, memory-related vulnerabilities, they're, I want to say, a high percentage of the vulnerabilities we find in static analysis and code review. Rust eliminates most of these vulnerabilities. So why are we not seeing more widespread adoption, especially in safety-critical systems?
So I think we have seen a good bit of adoption, but I would agree that it would not be widespread. Rust has been around for over 10 years now, and I'm starting to find in my experience that the adoption, or the obstacles to adoption rather, tend to come from a lot of developers in particular being told to really not use it, being told to use the languages that they're always, used to using, languages that their institutions have, adopted and become dependent on for so long. And at the times, right, or at least in my experience of what I've seen, is that anytime developers tend to drift from that, it's often met with institutional resistance because certain infrastructure has already been stood up to support other languages, and there just isn't the documentation there internally, I should say, to support those endeavors.
Mm. So also the workforce, right? There's not a huge workforce that have Rust on their resume. What's it going to take? How long would it take a workforce to get comfortable? Say a seasoned developer in C++.
Mm-hmm. Yeah,
what are we talking about here?
Yeah, that's actually a really awesome question because at first, as somebody who had only seen Rust for a little bit before I really started to use it for a real project, I personally admit that it took me a little bit of time to see it, to actually get in the groove with it. A lot of people tend to cite 3 to 6 months is a really good indicator for how long a developer could take to really get comfortable with a new language, and this is just in general. But back in 2022, Google actually surveyed a good bit of the Rust developers at the time, and it turned out that a lot of them only took 2 months to feel confident in writing Rust. Not necessarily before they could write productive code or actually solve a problem, but before they personally felt confident, which I think is actually a result of just being in a good shop of, and really, what's the word, right? Being a part of a culture that supports the ability to try, new innovative things like Rust.
That's great. I know. I don't know if everyone understands the cycle we spend now of fixing bugs in other languages that could be solved by using Rust. And so I always have a hard time understanding, why aren't we making the switch? Is it not painful enough yet? If I have a system that I want to be in existence for the next 30 to 50 years, which I have these systems, we're building them today, I'm not always seeing them start with Rust. I have the inclination to think it's because we're integrating with legacy. So when my legacy systems that I'm replacing are built in C, C++, Ada, there seems to be a tendency to stick with those languages. But if I want to go another 50 years, right, I really should think about looking towards Rust as a new programming language. What do we got to do to increase adoption?
I think to increase adoption really doesn't start with a technical solution right away. I think it really starts with looking at the culture that you've built over the last 50 years when you first had your system. Because I don't think there will ever be an end to, new programming languages coming out, new tools coming out, but really trying to look at the problem you're trying to solve and the tools you have at your disposal. Because as we said before, right, like some of these languages like C++ in particular require you to really put the work and the thought in ahead of time to understand, how you're going to really build the thing you're looking to build. So if you want to really start thinking about how you can last the next 50 years or so, you have to think about, starting right the first time, I'd say. Looking at the tools you have, seeing the problem you're trying to solve, and then trying to look holistically, right? Look at how you can start removing those small little obstacles, right? Small little pain points that we often see. When you say that if it doesn't hurt enough yet, I don't think that enough ever gets reached with a lot of institutions unless they really look inside and see, where are the places where time is being wasted? Is it being wasted debugging? Is it being wasted planning unnecessarily? Is it being wasted, double checking and rehashing old decisions? Sometimes a programming language isn't your only problem. Sometimes it really is a bit deeper than that.
It's fun. I know a lot of the SEIers here. There's been great podcasts, blogs on Rust already. I also know you actually have developed an open source project written in Rust. Can you tell me a little bit about that experience?
Absolutely, because this is the same project I had mentioned before when it was actually my first real project really using Rust, and it's called Polar. And it's trying to solve that observability problem I hinted at earlier that a lot of our customers tend to run into. Trying to figure out, not just where my data is, but how I can start to make use of it after it's already been generated and stored somewhere else, right? Out there in my ecosystem. Turned out to be like a really difficult problem for our customers and for me as well as I've gone to deploy applications. And, Rust particularly was the better choice for us because what we wanted was a way to interact with a large variety of different systems, but in a way that would enable us to design it with security in mind first. And Rust was chosen particularly because not just because of its various memory related safety features, but also because it compiles down to one single binary every time. So that allows us to very easily containerize it, ship and deliver it to our customers and to whoever else wants to use it, and then deploy it however we want to. So when I came to use Rust and to try to solve this problem, I ended up figuring out that the ecosystem is just there, right? Every little thing I wanted to do to interact with systems like AWS, Jira, GitLab, and other various APIs, there was always a kind of client, there was always a new package, there was always a crate. And, on top of that, the tooling inherently in the tool chain, their Cargo package manager, Cargo Clippy is another static analysis tool that comes shipped right as part of the tool chain. I actually ended up finding it to be quite enjoyable because I didn't really have to look outside of what I would call the official tool chain, if we were to use that word, for help, right? I didn't have to look for different third-party tools I would have to audit. I didn't have to, dive into what I would say to be very fragmented documentation. I found the experience to be very complete, is I guess for lack of a better word there.
So my worries of maybe 3 to 5 years ago where the developer experience wasn't great due to maybe a lack of supporting tooling, that's something of the past. It's time to dive right in.
I would absolutely say yes, because I think with every open source project there are going to be varying levels of documentation. But what I find particularly enjoyable about Rust is that it comes with a lot of those developer experience pieces built into it. So you don't just have built-in static analysis tools and a really solid package manager, but you also have something like the Rust doc generator, which will actually generate documentation from your source code. It doesn't just take markdown files or various JSON configurations or what have you. You can just write your documentation right there and then generate it, and you will have as much documentation as you've written fully accessible to anybody looking to consume your code.
Oh, that's fantastic. I guess a lot of us been programming for a while. We've used all kind of third-party libraries to generate docs. So
yeah,
Rust built-in documentation sounds like a way to move forward and get going on this.
Yeah, it's pretty awesome. I think it's part of what we at the SEI try to champion, right? And it's part of the DevSecOps approach to really developing software, right? Not just using the right tools, but letting those tools inform your processes and get the right information in the right people's hands.
All right, so you developed Polar. Tell me a little bit more about it. I'm a user. Where do I go to get this? What does it do? What can I expect from it?
For sure, yeah. Polar is available actually as an open source tool that we released, I think it was just last year now, which is a great anniversary, right? And if you're looking to look at it, if you're looking to get it, I would say, go ahead and check the SEI's GitHub. Take a look at some of the documentation and source code there. And that's where you really start to see, the work we've put into this and thinking about the problem. We actually have released Polar in the SEI's GitHub, so anybody who's really interested in seeing from a technical perspective what's been going on there should definitely check it out. There was a blog post just last year that was released, and we'll be happy to, release some links to that post, as well as, all of its other resources that were available there. But if you're a user looking to check it out, the first thing you should really do is definitely check out the source code. There are numerous files in there that will allow you to build the project, containerize it, and ideally actually deploy and ship it to your environment if you would really feel so desired. We put a lot of thought into how we can make it as easy and simple as possible, not just to use this project, right, but go through the motions of figuring out how to both verify, test, and then deploy this thing in whatever environment you see fit.
Great. So if I want to get into Rust and I want to look at this observability platform, I take it, just hop on our GitHub, download this Read doc, and get going.
Yeah, we've really tried our best to not just to follow the right practices, right, but to think of the people who really have just not only never used Rust before, right, but really tried to tackle this problem of observability that we're trying to face. There are just no shortage of tooling. There's no shortage of tools out there that will let you take data from any particular place, right? But the unfortunate aspect of this is that all of these tools, all of these different solutions really only try to take data from maybe one or two particular places at a time, right? And mostly they're incentivized to only show you what they want you to see, to only give up only so much, right? Because that, at the end of the day, turns into a real look at their own internal workings. So I think there's just so much to go into with that.
So I'd love to bring you back to find out what else you've been doing in Rust. So what does the future of Rust look like for you? What are you and your team working on?
Absolutely. There are various microservices at the core of Polar's framework, and we're trying to mostly anticipate a lot of the more valuable data sources that customers will want to pull data from. So, we already have some services to pull data from GitLab. Others are working on ones for Jira, and even, various cloud providers like Azure and AWS. But aside from Polar, what I'm really looking forward to doing is building out more resilient developer platforms. This also involving tools like Nix, tools like Doll, and various other types of languages that will allow people to kind of not just kind of think in different paradigms, but also kind of try to move the needle as far as how we can really change the game and thinking about not just how we build software, but how we work together to do it.
Vaughn, thanks again for joining me this afternoon. Love to hear about your team and what they're doing in Rust. For our audience, we will include links in the transcript to resources mentioned during this podcast. As a reminder, this podcast is available pretty much everywhere where you get podcasts, including Apple Podcasts, SoundCloud, Spotify, and the SEI's YouTube channel. If you like what you see and hear today, give us a thumbs up. Thanks for joining us.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, TuneIn Radio, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.